The service disconnecting means is installed at a readily accessible location, either outside of a building or structure or inside, nearest the point of entrance of the service conductors. This is to provide a convenient and safe way to disconnect all conductors in a building or other structure from the service entrance conductors. This is important for safety reasons, as it allows the power to be turned off quickly and easily in the event of an emergency, such as a fire or an electrical fault. The term point of entrance is defined in the National Electrical Code (NEC) as the point at which the wire or cable emerges from an external wall, from a concrete floor slab, or from a rigid metal conduit or an intermediate metal conduit grounded to an electrode in accordance with Section 800.40b. This means that the service disconnecting means must be installed as close as possible to the point where the service entrance conductors enter the building. The NEC does not specify a maximum distance that the service entrance conductors can travel into a building before a disconnect is required. However, most jurisdictions have adopted local ordinances that specify a maximum distance, such as 5 feet, 10 feet, or 15 feet. The reason for this is to ensure that the service disconnecting means is located in a convenient and accessible location. The difference between 5 feet or 15 feet is that the shorter distance provides a greater level of safety. If the service entrance conductors are located further inside the building, it may be more difficult to access the service disconnecting means in the event of an emergency. The real reason that this disconnect is being installed is to provide a convenient and safe way to disconnect all conductors in a building or other structure from the service entrance conductors in the event of an emergency. To elaborate on the requirements for service disconnecting means, let's delve into the specific aspects that the NEC addresses. Firstly, the NEC mandates that the service disconnecting means must be readily accessible. This means it should be located where it can be reached quickly and without obstruction. Factors such as locked doors, stacked materials, or excessive height can impede accessibility and are therefore not permitted. Secondly, the NEC emphasizes the importance of identifying the service disconnecting means. Clearer and permanent labeling is required to indicate the purpose of the disconnect. This ensures that in an emergency, personnel can quickly identify and operate the correct disconnect to energize the electrical system. Thirdly, the NEC addresses the number of service disconnecting means allowed. While a single service disconnect is generally preferred, the NEC permits up to 6 service disconnecting means in a single enclosure or group of enclosures. This allowance is intended to provide flexibility in larger installations where multiple disconnects may be necessary. However, it's crucial that all disconnects are clearly identified and grouped together to avoid confusion. Fourthly, the NEC specifies requirements for the interrupting rating of the service disconnecting means. The interrupting rating must be sufficient to interrupt the available fault current at the service entrance. This ensures that the disconnect can safely interrupt a fault current without failing, which could lead to equipment damage or personal injury. Fifthly, the NEC addresses the grounding and bonding of the service disconnecting means. Proper grounding and bonding are essential for electrical safety. The service disconnecting means must be properly grounded to provide a low impedance path for fault current to return to the source, which helps to activate overcurrent protective devices and clear the fault quickly. Furthermore, all metallic enclosures and components of the service disconnecting means must be bonded together to create an electrically continuous path. Sixthly, the NEC includes specific requirements for service disconnecting means installed in hazardous locations. In hazardous locations, such as those containing flammable gases or vapors, the service disconnecting means must be listed for use in those locations. This ensures that the disconnect is designed and constructed to prevent ignition of the hazardous atmosphere. Seventhly, the NEC provides guidance on the location of the service disconnecting means in relation to other equipment. The service disconnecting means should be located away from readily ignitable materials and should not be installed in bathrooms, toilet rooms, or similar locations. This helps to prevent fires and electrical hazards. Eighthly, the NEC addresses the height of the service disconnecting means. The operating handle of the service disconnecting mean should be installed at a height that is readily accessible to qualified personnel. Generally, the NEC recommends a maximum height of 6 feet 7 inches for the operating handle. Ninthly, the NEC requires that the service disconnecting means be suitable for the environmental conditions in which it is installed. If the disconnect is installed outdoors or in a damp location, it must be listed for use in those environments. This ensures that the disconnect can withstand the elements and continue to operate safely. Tenthly, the NEC addresses the coordination of overcurrent protective devices. The overcurrent protective devices protecting the service entrance conductors must be coordinated with the service disconnecting means to ensure that they operate in the correct sequence. This helps to prevent nuisance tripping and ensures that the electrical system is properly protected. It is important to note that the NEC is a comprehensive document, and these are just some of the key requirements for service disconnecting means. It is essential to consult the NEC and any applicable local codes for complete and accurate information. The NEC is updated every 3 years, so it is important to use the latest edition of the code. The NEC is developed by the National Fire Protection Association (NFPA) and is widely adopted by jurisdictions throughout the United States. In addition to the NEC, many jurisdictions also have their own local electrical codes that may be more restrictive than the NEC. It is important to be aware of and comply with all applicable codes and regulations. The service disconnecting means is a critical component of any electrical system. By following the requirements of the NEC and any applicable local codes, you can ensure that the service disconnecting means is installed correctly and operates safely. This will help to protect people and property from electrical hazards. It is always best to consult with a qualified electrician to ensure that your electrical system is installed correctly and meets all applicable codes and regulations. A qualified electrician has the knowledge and experience to properly design and install an electrical system that is safe and reliable. They can also help you to troubleshoot and repair any electrical problems that may arise. Remember, electricity can be dangerous, and it is important to take precautions to protect yourself and others from electrical hazards. Always turn off the power before working on any electrical equipment, and never touch electrical wires or components with wet hands. If you are not comfortable working with electricity, always call a qualified electrician. Furthermore, consider the specific nuances of the point of entrance definition. The NEC definition is quite precise, focusing on the physical location where the conductors penetrate the building's exterior. This is not necessarily the closest point to the utility service drop or lateral, but rather where the conductors first enter the building envelope. This point often dictates where the service equipment, including the disconnecting means, must be located. The intent is to minimize the length of unprotected conductors inside the building. Conductors before the service disconnect are not protected by an overcurrent device, like a circuit breaker or fuse. Therefore, any fault on these conductors could result in a fire or other hazard. By keeping this length to a minimum, the risk is reduced. Different building construction types can influence the determination of the point of entrance. For example, in a building with a concrete slab foundation, the point of entrance may be where the conduit emerges from the slab. In a building with a crawl space, the point of entrance may be where the conductors pass through the foundation wall. The type of wiring method used also affects the point of entrance. For example, if the service conductors are run in rigid metal conduit, the point of entrance is where the conduit enters the building. If the service conductors are run as service entrance cable, the point of entrance is where the cable enters the building. It is also important to consider the potential for future modifications or additions to the building. If the service entrance conductors are located in an area that is likely to be remodeled or expanded, it may be necessary to relocate the service disconnecting means. This can be a costly and time-consuming process, so it is important to plan ahead. In some cases, it may be possible to install a second service disconnecting means to serve a new addition or area of the building. However, this must be done in accordance with the NEC and any applicable local codes. The OJ, or authority having jurisdiction, is the entity responsible for enforcing the NEC and any applicable local codes. The AHJ may be a local building inspector, a state electrical inspector, or another qualified individual. The AHJ has the authority to interpret the NEC and to make decisions about the installation of electrical equipment. It is important to work with the AHA to ensure that your electrical system is installed correctly and meets all applicable codes and regulations. The AHA can provide guidance on the location of the service disconnecting means, the type of wiring method to use, and other aspects of the electrical installation. The AHA can also conduct inspections to ensure that the electrical system is installed in accordance with the NEC and any applicable local codes. It is important to cooperate with the AHA and to address any concerns that they may have. In addition to the NEC and the AHA, there are other resources available to help you understand the requirements for service disconnecting means. These resources include electrical contractors, electrical engineers, and electrical inspectors. Electrical contractors can provide guidance on the installation of the service disconnecting means and can ensure that the installation is done correctly. Electrical engineers can provide guidance on the design of the electrical system and can ensure that the system meets all applicable codes and regulations. Electrical inspectors can conduct inspections to ensure that the electrical system is installed in accordance with the NEC and any applicable local codes. By working with these resources, you can ensure that your electrical system is safe and reliable. In summary, the location of the service disconnecting means is a critical aspect of electrical safety. By following the requirements of the NEC and any applicable local codes, you can ensure that the service disconnecting means is installed correctly and operates safely. This will help to protect people and property from electrical hazards. Always consult with a qualified electrician to ensure that your electrical system is installed correctly and meets all applicable codes and regulations. Remember that electrical codes are in place to protect lives and property, and compliance is not optional. Always prioritize safety when working with electricity, and never attempt any electrical work that you are not qualified to perform. Your local utility company can also provide valuable information regarding service entrance requirements and local codes. They often have specific guidelines for connecting to the grid and may have additional requirements beyond the NEC. Contacting your utility company early in the planning process can help avoid delays and ensure a smooth installation. Remember, proper electrical work is essential for the safety and functionality of any building. Always prioritize safety, follow the codes, and consult with qualified professionals.